Hello friends, I welcome you all to this class. This is mathematics class, and today we'll be looking at this second example on this topic we introduced in our previous class, continuity of functions. So we saw how to find the interval of continuity of a given function. So we considered that in our previous class. So, and I told you that we'll be treating this topic with some examples. So we are looking at this second example. They said the value of k for which the function f of x equals, so the function takes value x squared minus 25 divided by x minus 5 when x is not 5, and it takes value k when x is what, 5. And they want us to find that value of k for which this function is continuous at x equals what, 5. So which means that we are going to assume that what, the function is what, continuous, right? Because they asked us to find the value of k at which the function is continuous. So we assume that the function is continuous at x equals 5, and we are going to find this point k that will make this function to be continuous at that point x equals what, 5. So I'm going to use limit definition of continuity. So we are going to assume that this function is continuous at x equals 5, right? And that we'll find the point k that will make it to be what, continuous. I'm going to use the limit definition of continuity. So I say that this function f of x is continuous at x equals 5 if limit as x goes to that point 5, as x goes to 5 of f of x is equal to f at the point 5. So this means that this function is continuous at x equals 5 if limit as x goes to 5 of the function f of x is equal to the value of the function at that point what, 5. Now limit as x goes to 5 of f of x will be equal to limit as x goes to 5 of, so we look at the f of x. This is we have the function given to us here. F of x is what, x squared minus 25 divided by x minus 5, right? Divided by x minus 5. Remember this second value of x, remember the second value of the function is what, k, when x is what, 5, and this will give us what, f at 5. Because the value of the function when x is 5, that's f at 5, is what, k. So we are now evaluating the limit of this function as x goes to 5. That's, we consider this value of the function and evaluate the limit. So if you want to evaluate the limit, you substitute the point, x is going to 5. So substitute the point 5 here. You are going to have 5 squared minus 25, right, divided by 5 minus 5. So I'm replacing x with 5 because that's how to evaluate limits. X is going to 5. So 5 squared is 25 minus 25 divided by 5 minus 5. Of course, 25 minus 25 will give us 0, and 5 minus 5 will give us 0. So we have 0 over 0. Whenever you are evaluating limits and you get 0 over 0, you can simply use what? Hospital's rule. Using Hospital's rule. So we use the Hospital's rule to resolve it because we are getting 0 over 0. It's an indeterminate expression. So by using the Hospital's rule, we're going to have the limit as x goes to 5 of x squared minus 25 divided by x minus 5 will be equal to limit as x goes to 5 of, so if you want to use the Hospital's rule to resolve this, you will differentiate the numerator separately and differentiate the denominator separately. So if I differentiate the numerator, if I differentiate x squared, if you bring down the power, you are going to have 2x. Then if you remove 1 from the power, if you remove 1 from 2, you have power x raised to power 1. So basically the answer is 2x. Then if you differentiate 25, you get what, 0, because the derivative of a constant is what, 0. So basically numerator is giving us 2x. Then if you come to the denominator, if you differentiate x, you get 1. If you differentiate x, you get 1. If you differentiate minus 5, you get 0 because 5 is a constant. Minus 5 is a constant. So basically we have this. So limit as x goes to 5 of 2x divided by 1. So x, we substitute x for what? 5. So evaluate this limit. That's 2 multiply 5 divided by 1, which is 10 divided by 1, which gives us what? 10. Okay, so it means that the value, the limit of the function as x goes to 5 is what? 10. That's what we got here. But we assume that what? We assume that this function is what? Continuous. That the limit as x goes to 5 of f of x must be equal to what? F at what? 5. So from what I solved here is that I first of all evaluated the limit of the function as x goes to what? 5, because that's the point. X goes to 5. So after the evaluation, we got the limit to be what? 10. But we assume that this function is what? Continuous, which means that the limit as x goes to 5 is equal to the value of the function at what? 5. But what is the value of the function? When x is 5, value of the function is what? K. So it means that this k is equal to the limit as x goes to what? 5. So but what is the limit we got? 10. So which means k is 10. So this gives us the value of k that will make this function to be continuous. So thank you so much for being part of this class. See you in our upcoming class. Bye.